Your GPA. Guess what that is? It's a weighted average. How's it weighted? We just know it is. What are the weights? What are the weights in your grade? How many credits your courses are? This is a 4-credit class, yeah? 4-credit class, total fit, 1-credit class. That means that class counts 1/4 of what this class counts towards your GPA.
So even if you get an A, it doesn't matter.
If you, it matters less than an A in a 4-credit class, right? It matters 4 times less towards the overall sum of your grades. It's very tempting to say like, oh, I got a C in Math 105, I got an A in total fit, add them together, divide by 2, that's a B. It's not. It's like a C+. Because that C counts 4 times and the A only counts once. So you got to make sure when you're thinking about that in a situation like that, also a situation like this, also life insurance, also health insurance.
I didn't know that 2 years ago.
Well, you know it now and that's okay. This is why all students take 105 when they first get here and 243 when the next term they're here. Because that's when you learn stuff like that. It's all good. It's all good. All right, let's do it. So the average number of flips until we saw eating each of the heads at least one time. Okay? We've got to do 2 times 167 plus 3 times 67 plus 4 times 37 plus 5 times 15 plus, we had 7330, 6 times 7, I'm going to come down to this line now, plus 7 times 3 plus 8 times 3 plus 9 times 0, so actually I can leave that one off. Is that okay if I just leave that one off? Because it's times 0 anyway. Plus 10 times 3 plus 11 times 1.
So just plus 11.
That's plus 11, that's fine. Oh, the 1 just makes you know that there's a frequency attached to each one. You're absolutely correct, just plus 11 is fine. Divided by, we have to know how many times we flipped altogether. I've got 303 in the record up here, which means I can't count. Because since I told you each to do it 10 times, and I'm guessing there's 30 of you in the room, this should have been 300. So I can't count, ish.
Well,
that's okay.
I did 2 trials.
Oh, I did 2 trials, so I'm off by 1. I can live with that. I can live with being off by 1. So, if you want, you can calculate this. In the interest of time, I've got Excel calculating it for us. The average is about 2.9. I've got Excel doing it for just in the interest of time. Yeah, I think you guys can plug that through your machine and get an answer. I think you can. So I've got Excel doing it. There's a really fun function in Excel called sum product, which allows you to take the product of a bunch of things and then add them all up at once, which is what I'm using to do that command. So the average, in this case, is about 2.9 flips. Isn't that interesting? Isn't that interesting? Because you'd think, if you flip a coin, half the time, you're going to go heads, tails, or tails, heads, and be done. So it almost seems like 2 should be the average, yeah? Because that happens the most. And look, it did happen the most. But the thing is, it only happens half the time. The other half the time, you're going to start with heads, heads, or tails, tails. Right? This is if you start with heads, tails, or tails, heads.
So the bottom number, the 303, that's just adding up the...
Yes, ma'am.
Yeah.
Or, Tammy, thought another way, adding up that plus 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 that. Same exact thing.
Right.
That's why I like the 1 to be in there too when you answer your question again. It's a great question. And Aaron's question. That's why I like having the 1 in there, because you can see the connection between the data and the calculation. So back to my kind of argument. I want to tie it back into the last experiment. Look at the difference in graphs. Isn't it cool? There's your first graph. And here's your second one. What does that look like? What does that look like?
Exponential.
Oh, doesn't it? I like what both of you guys said. I heard exponential and I heard asymptotic. Doesn't it look kind of like the exponential decay models that we've been studying the past couple days? It sure does, because it is. It has to be. You're half as likely to take the next flip each time. Each flip should only happen half as many times. Think about it this way. Think about it this way. This, heads, tails, tails, heads, you're done. This is heads, heads, tails, tails, but it also requires 1 more flip, thereby getting rid of half of you. See, each extra flip gets rid of half of you again. Think of it that way. Each extra flip gets rid of half of you again. So with each additional flip, we lose half more. It's not perfect, right? It's not perfect. It goes from 167 to 67. That's not exactly right. This should be double this, but it's roughly double that. Then it goes 67 to 37, 37 to 15, 15 to 7, 7 to 3. That looks like halves, doesn't it? If you look at those quotients, if you do first quotients from here to here, here to here, it looks almost like a half. It's pretty damn close. And perfectly exponentially, it should be. It should have been. Exactly half of you should have been at 167. It's pretty close. We had 303, and you had 160. You were a little bit high, but still damn close for experimental data. I like that. Cool? Everybody buying this logic? Yes, it most definitely is exponential in this case, for sure. Absolutely, for sure. Okay, now it's also nice because you have the basic behavior of a coin going on. What I want to do next is, I want to switch over to the cards. So I want to repeat the exact same 2 experiments we just did, but instead of using the coins, I want to use the cards. So this is why I said not every one of you had to have a deck of cards. I have an in-class quiz for us to do. So get in pairs. Each pair just needs 1 deck of cards and a quiz between them. Okay? So not everybody needs a deck of cards. If we need a deck of cards, spread them out. Here's your quiz. Here's your quiz. Absolutely. Yes. So each pair just needs 1 quiz too. 1 deck of cards, 1 quiz. You'll put both your names on the same quiz.
Anybody not have a friend? Anybody need that?
Playing poker already, very nice. Oh, playing 21. Gotcha. You both got 21? What happens then? Oh wait, whoever got it first wins it. Right? Oh. Be in the house. Celebrate it because it doesn't happen often. Outlier. Well, we're mad at craps. I mean, honestly, because one person's going to get one person's going to. If you don't want to get bored, sure. It just might get boring. But that's okay. You don't mind getting bored. It's okay. It's alright. I just don't want you to get bored. Well, then don't worry about it. Well, thank you. No. Oh, damn. It was such a slick move, except it wasn't. Alright, so it's a little wordy. Let me just walk it through it real quick. You're gonna be doing the same experiments we just did, but instead of using a coin, you're shuffling cards out to people. Please realize, read it carefully. How many times would you have to be, this is question number 1, how many times would you have to be dealt a card from a shuffled deck until you're reasonably sure you get a repeated suit? You have to reshuffle the deck each time you throw a card out. So you're gonna throw it, so what I did, I used Excel to simulate it, but here's what I would do. I shuffled the deck, threw a card, got a club, made a note of that, put the card back in the deck, shuffled it again, next card came out, it was a diamond, put that card back in the deck, shuffled again, then I got a heart, put that card back, and then I got a club on the 4th trial, so it took me 4 until I got a repeated suit. It took me 4 until I got clubs twice. It doesn't matter what suit repeats as long as it's a repeated suit. It doesn't have to be the first one. If it had gone clubs, diamonds, hearts, hearts, that would have been a repeat because I got 2 hearts. If it had gone clubs, diamonds, hearts, diamonds, that would have been a repeat. So stop when you get a repeat and just make a note of how many deals it took to get that repeat. And do that 10 times. Not the first one that you see. Not the question. No, just any repeat at all. It's exactly the same as Mondays with the cards and the coins. Exactly. You guys can be a pair. Perfect. You guys can be a pair. Excellent.